In this method, or in other words, this method will be called as the difference of two squares method. So here method number 3 of factorizing the given expression or the given polynomial, that is difference of two squares method. So here in this method we express the given expression as the difference of two squares, then we factorize it by utilizing the identity a square minus b square as a plus b into a minus b. So here in this method first we express the given polynomial as or given polynomial in the form of difference of two squares then we factorize it. We factorize it mean the given polynomial will be factorized by using the identity, that is a square minus b square equals to a plus b into a minus b. So in this manner, so we will factorize the given expression by means of the method called the difference of two squares. First of all, we will express the given polynomial in the form of the difference of two squares, that is these are the squares, this is the given expression, that is modified in the form of the difference minus sign, the difference of the two squares. One first square is of a square, the second square is of b square. Then later we will utilize the identity, that is a square minus b square, that is a plus b into a minus b, in order to factorize the given polynomial. Then now under this we are going to perform one example. For instance, factorize 5p square minus 80q square. So we have to factorize 5p square minus 80q square. So always our concentration must be on the identity, that is identity is of a square minus b square. So here we can write as p square, but say coefficient is of 5, we cannot express it as the, we cannot express 5 as the perfect square. And similarly q square is a perfect square, but 80 is not a perfect square, we cannot write it as a perfect square. But we have to, in order to factorize it, so first of all we have to write as the difference of the two squares or difference of two perfect squares. Then only we can utilize the identity, that is a square minus b square, as a plus b into a minus b. So solution starts now. The given expression is of 5p square minus 80q square. So this is our given expression. Then in order to factorize it, we have to write the two terms which are given in the expression as the perfect squares. Then now that implies, so I am going to take 5 as common in the given expression. When 5 is taken out as common in the first term, that is 5p square, 5 is taken out as common, just p square is left over within the bracket. Whereas 80 is as the second term, so here the coefficient is of 80, 80 can be split as, so we can write 80 as 5 into 16, 16 5 is of 80. So here when 5 is taken out as common, then now 5 16ths is of 80, then q square written as it is. Then now that implies 5 taken out as common, in order to write the difference of two perfect squares. So p square can be written as p whole square minus 16 can be written as 4 square. So here 16 can be written as 4 into 4 as 4 square. And q square is written as it is. Then now that implies 5 written as it is before the bracket, p whole square then square is applicable. Say here 4 square and q square, say here square is common for, that is exponent is common for both 4 and as well as q. So here it is in the form of ab whole power m, that is a to the power of m into b to the power of m, whereas 4 square q square is in the form of a power m into b power m. So exponents are equal here, m and m. Here also the exponents are equal, 2 and 2, that is m stands for 2, whereas a value is of 4 and b value is of q. We can write it as a power m into b power m as ab whole power m. So here minus ab, a is of 4 and b is of q, so whole to the power of same exponent must be written here, the same exponent is of 2, so overall we can write it as the whole to the power of 2. So here we got this logical step by utilizing this reason, that is ab whole power m equals to a power m into b power m. That implies the next logical step will be off. So here in this manner we wrote the given expression as the difference, that is minus sign, difference of the two perfect squares. Here the two perfect squares are of, one as p square, the other as 4q whole square. Then here I can utilize the identity, that is a square minus b square as a plus b into a minus b, in order to find out the factors of the given expression by means of the method called difference of two squares. Here by utilizing this identity we can write it as phi written as it is. So here a square stands for here p square, and here minus, and here b square stands for 4q. So here we can express a as p and b as 4q, a as p and b as 4q, but it is in the form of a square minus b square, that is p square minus 4q whole square. Then the result will be of a plus b into a minus b. So we can express p square minus 4q squares as the factors of a plus b into a minus b. So here a value is of p plus b value is of 4q, bracket close, and the next factor is of a minus b. So here a is of p again minus b is of 4q. So here in this manner, so here we got the result as 5 into p plus 4q into p minus 4q. Hence the given expression is of 5p square minus 80p q square can be written as 5 into p plus 4q into p minus 4q. So here these are the three factors of the given expression, that is 5p square minus 80q square, by utilizing the method number 3, that is difference of two squares. So here hence therefore 5 is one factor and p plus 4q is the second factor, and p minus 4q, these three are the factors of given expression, that is 5p square minus 80q square. In the similar manner, let us perform one more example, that is example number 1. So in this example number 1, so we are going to factorize two x plus 3y whole square minus 25z square. Then now the solution starts. The given expression is of 2x plus 3y whole square minus 25z square. So first of all we have to write the given expressions as the squares of the difference of the squares, difference of the two perfect squares. So first one is a perfect square, 2x plus 3y raised to the power of 2, it is a perfect square, whereas 25z square is not a perfect square, we have to write it as, so here as a perfect square. Then that implies, as per the method, that is difference of two perfect squares. 2x plus 3y whole square, first term is written as it is, minus 25 can be written as 5 into 5 and z square written as it is. That implies 2x plus 3y whole to the power of 2 minus 5 into 5 can be written as 5 square into z square. That implies 2x plus 3y whole square minus, so a square is it is in the form of a power m into b power m can be written as ab whole power m. So based upon this reason, so I am going to write 5 square into z square as 5z whole to the power of 2. So here m is of 2 and in the case of b power m, so m is of 2. A and b values are of 5 and z. So here the exponents are same and this bases are of different, that is 5 and z. So it can be written as a into b whole power m. So here 5 into z, the exponent is same. So we wrote as m. So here exponents are same, 2 and 2. We wrote it as to the power of 2. Now this is the difference of the two perfect squares. So here now we can apply the formula, that is as per identity. As per identity, that is a square minus b square is equals to a plus b into a minus b. So we can write it as, so that implies 2x plus 3y whole square minus 5z whole square. So now by comparing, so here a is of 2x plus 3y and b is of 5z. So here a square, that is 2x plus 3y whole square. So a value will be of 2x plus 3y and b value is of 5z. So in order to get the result, say that equals to, factors are of, so your first factor, that is a is of 2x plus 3y plus b value is of 5z, bracket close, into a is of again 2x plus 3y minus b is of 5z. So that equals to 2x plus 3y. Now we are going to remove the small brackets within the square brackets. 2x plus 3y plus 5z written as it is, then as the first factor, then the next factor will be of, when brackets are removed, so before this bracket there is a positive sign, there won't be any sort of changes in their signs. So 2x plus 3y remains same minus 5z. So in this manner, so here I got, so here therefore 2x plus 3y whole square minus 5z whole square is equals to 2x plus 3y plus 5z into 2x plus 3y minus 5z. So here hence 2x plus 3y whole square minus 5z whole square is nothing but 25z square. So 25z square, which is equals to 2x plus 3y plus 5z into 2x plus 3y minus 5z. So in this manner, I say here we got these two as the factors of the given expression, that is 2x plus 3y whole square minus 25z square. Hence so here 2x plus 3y plus 5z, 2x plus 3y plus 5z and 2x plus 3y minus 5z are the factors of the given expression, that is 2x plus 3y whole square minus 25z square. 2x plus 3y whole square minus 25z square.